Good morning everyone. Today I am going to explain the fetch execute cycle, which is one of the most important processes in computer architecture. Every program that we use on a computer, whether it is a browser, a game, or Microsoft Word, works because the CPU repeatedly performs the fetch execute cycle. This cycle allows the processor to read instructions from memory, understand what each instruction means, and then carry out the required task. In this presentation, I will explain what the CPU is, the three stages of the fetch execute cycle, the components involved, and why this process is essential for every computer system. Before we understand the fetch execute cycle, we first need to understand the CPU. The CPU stands for Central Processing Unit, and it is often called the brain of computer because it processes all instructions. The CPU contains three important parts. The first is the control unit, which manage and control all operations inside the computer. The second is the arithmetic logic unit, also known as ALU, which performs mathematical calculations and logical comparisons. The CPU also contains registers, which are very small and very fast memory locations, used to temporarily store data and instructions. The CPU works together with RAM to execute programs quickly and efficiently. What is the fetch execute cycle? The fetch execute cycle is the process that the CPU follows to execute every instruction in a program. It has three stages. The first stage is fetch, where the CPU retrieves an instruction from memory. The second stage is decode, where the control unit interprets the instruction and determines what action needs to be performed. The third stage is execute, where the CPU performs the required operation such as carrying out a calculation, moving data, or storing information. This cycle repeats continuously millions or even billions of times every second while the computer is running. Several components work together during the fetch execute cycle. The CPU controls the entire process. RAM stores the program, instructions, and data that CPU needs. Registers provide very fast temporary storage inside the CPU. The program counter, or PC, stores the address of the next instruction to be executed. Memory address register and memory data register. It is used to communicate with memory. And then finally, the control unit decodes instructions, while the ALU performs calculations and logical operations. All of these components work together to ensure that instructions are processed correctly. Now, the first stage is called fetch. At the beginning of this stage, the program counter contains the memory address of the next instructions. The CPU sends this address to memory and retrieves the instruction. After the instruction has been fetched, it is placed into instruction register. The program counter is then updated so that it points to the next instruction. This prepares the CPU to continue processing the following instruction after the current one has been completed. Let's look at an example. Suppose the instruction stored in memory is load R100. The word load tells us that CPU it needs to copy data. R1 represents a CPU register and the number 100 represents some memory location. During the fetch stage, the CPU retrieves this instruction from memory. The instruction is then ready for decoding so that the CPU can understand exactly what needs to be happen. This example shows how instructions move from memory into the processor. Second stage is decode. Here the control unit examines the first instruction. It identifies the operation that needs to be performed and data involved. For example, it determines whether the instruction is asking the CPU to add numbers, subtract values, move data, or compare information. The control unit then prepares the CPU for the next stage by sending the correct signals to the appropriate hardware components. Without decoding, the CPU would not how to interpret the instruction correctly. The third stage and the final stage is execute. During this stage, the CPU performs the required action. If the instruction involves a mathematical calculation, the ALU performs the calculation. If the instructions involves moving data, the CPU transfers the data between memory and registers. After the operation is complete, the result is stored either in a register or back into memory. Once execution finishes, the CPU immediately begins fetching the next instruction and the entire cycle repeats. Let's review the complete process. First, the CPU fetches instructions from the memory. Next, the control unit decodes the instruction to understand what action is required. Finally, the CPU executes the instruction by performing the operation. This continuous cycle allows computers to run applications, process data, and respond to user commands. The fetch execute cycle is one of the most fundamental concepts in computer architecture because every program depends on it. So, without this process, a computer would not be able to execute any instructions. Now, I will explain the loading data stage. After the CPU fetch and decodes an instruction, it often needs data to complete the task. This data is transferred from RAM, which is the computer's main memory, into the CPU registers. Registers are very small but extremely fast memory locations inside the CPU. As shown in the diagram, the memory controller manages communication between RAM and the CPU. The addresses lines identify where the data is stored. The data lines transfer the information and control signals coordinate the transfer. Once the required data is loaded into the registers, the CPU can process it quickly and continue with the execution stage. Now let's discuss the importance of the fetch execute cycle. First, it allows the CPU to process instructions efficiently by following the same sequence of fetch, decode, and execute for every instruction. This ensures that programs run accurately and smoothly. Second, understanding the fetch execute cycle provides the foundation of computer architecture. It helps us understand how the CPU, RAM, registers, and other hardware components work together to run software and process data. In simple terms, without the fetch execute cycle, a computer would not be able to execute programs or perform any useful tasks. And at the conclusion, to conclude, the fetch execute cycle is the process that enables the CPU to execute every instruction in a computer program. The cycle consists of three stages: fetch, decode, and execute. The CPU works closely with RAM, registers, the control unit, and the ALU to complete each instruction quickly and accurately. Understanding this process helps us understand how computers work internally and why the CPU is often called the brain of the computer. Thank you very much for listening. I hope this presentation has helped you understand the fetch execute cycle. Thank you so much.